Let's get introduced to limits. The worm says there's no limit, so we're going to learn out what that means. This PowerPoint is going to be a little more conceptual. There's not really going to be problems for you to do in it. It's more about ideas that are going to help you for calculus next year. So you're going to watch through this video, and then the next video you're going to get to learn about limits, and that's going to be with a different teacher, Krista King. So today we're going to talk about concavity, concave up, concave down, points of inflection. We'll review the algebra topics, and then you're going to go on and watch the next video where Krista King explains limits. So in geometry, you learned about a tangent, and you learned that we have a circle and we have a tangent line, and a tangent touches it at one place. Well, imagine we have a parabola and then we draw a line that touches it at one place. That would be the tangent line, the slope of a line that touches the graph at one point. So if we have the red parabola and the purple line, what could the slope of the line tangent to the red graph be at f of 2, negative 2? So that means when this is negative 2, we're right here, and we have this sort of line coming down. It's a little hard to draw. That would just touch at one point, and we want to know what the slope is. Well, it's probably going to be something pretty steep, maybe like negative 4 or something like that. If we go to the slope here at negative 1, and then maybe that's negative 2. And then if we go to this purple slope that's already here, the purple line, then that's going to be a slope of 2. So we went from negative 4 to negative 2 to positive 2. So you can see that the slope is increasing. We call this red graph concave up, and the slope, as we read it from left to right, the slope of the tangent is positive. So when we put this together, the slopes of the tangent are increasing from left to right and a concave up figure. If it's concave down, so let's say this one had a slope of 1, this one would have a slope of 0, this one would have a slope of negative 1. So now you can see that the values are decreasing of the tangent slopes. What is happening to these slopes as you read them from left to right? The slopes are decreasing. So when it's concave down, even though it looks like you're going up first, it's still concave down. The slopes are decreasing from left to right. So can you try to sketch a concave down where the slopes are decreasing? Write numbers in as your slopes. Something like, this is pretty steep, so maybe this is 3. Maybe this is 2. Maybe this is 1. Then we're at 0. Then negative 1. Oops, then negative 2. Then negative 3. And you can see we're decreasing. Can you draw concave up with slopes decreasing? Concave up with slopes decreasing. Well, this is a pretty steep negative, but then that's not so steep. No, this is not possible. So regardless of the sign of the slope, positive, negative, or 0, the slopes of the tangent are decreasing when you move from left to right when it's concave down. Concave down, the slopes are decreasing. And when it's concave up, the slopes are increasing. Just another recap. What about this one? Well, part of it's concave down, part of it's concave up. But when can you tell? Like, when does it switch from concave down to concave up? That point is called the point of inflection, or POI. It's the point where it does switch, and that point comes on a line that has to go through it. So the tangent line to a graph at a point of inflection must cross the graph at that point. We're going to switch over to continuous versus discontinuous. A graph is continuous if you can draw it without picking up your pencil. So that would be a continuous graph. A function is continuous when for every value c of its domain, f of c is defined. So there is a value at every x value. If it's discontinuous, you need to pick your pencil up when you're drawing it. When have we seen this happen? We've seen it with piecewise graphs, holes, and even asymptotes. So this is going to set us up to get ready to learn about limits. Remember our end behavior at the limits. As x approaches a number or infinity, so remember if we have, say, an asymptote at negative 2 and y equals 0. And remember we did when x approaches -2 from the left, we said that y would approach positive infinity. This is going to help us start figuring out what the limit is, what the limit is approaching. There are 3 types of discontinuity that we're going to be learning about. A point, which is removable, and then jump and infinite, which are non-removable. The point is a graph with a hole and a point at that hole. So we've graphed holes before. Remember, a hole is going to be when you have the same factor in the numerator and the denominator, and then you end up simplifying that to 1. So at x equals -2, we would have a hole. That's not this case, but we would have a hole. But then notice there's another point. So if we were asked what the value is of that point, the y value, that's different than the y value down here. We have a jump, which is a non-removable. You can see it looks like you have to jump to the other part of the graph. This is a piecewise graph. And then we have our infinite ones, and these are graphs with asymptotes, and we're going to be describing how they approach infinity. Let's take a stroll down memory lane and all of the things that we've learned this year. We go back even to Algebra 1 when we learned to graph lines. So when we start to learn limits, all of this algebra and Algebra 2 are going to come back for us. So we have to have those skills ready to go. You need to be able to graph lines. Graphing piecewise, we did that back in September. Factoring, you've got to be able to factor. Multiplying a binomial, make sure you are doing it correctly and writing out 2 sets of parentheses before multiplying through. Multiplying by the conjugate. So if we have 3 plus the square root of 2, then we can multiply by 3 minus the square root of 2 to simplify that denominator. Simplifying a complex fraction. We have a fraction over a fraction. We need to get a common denominator, multiply by the reciprocal, and then simplify. Simplifying a rational expression. This usually means factoring and then seeing what simplifies to 1. Remember our P and Q rule. This image has the N's in N and M, but we did P and Q. So you're going to have to remember when is it y equals 0? When is it y equals A over B? And when is there just no horizontal asymptote? Describing the asymptotes, the left and right behavior. Remember, if we say 0 to the plus, that means 0 from the right. And if we say 0 to the negative, that means 0 as it approaches 0 from the left. So we're going to have to remember that notation. All of these things will help us find the limit. So the next thing you're going to do is go over and watch the video by Krista King as she explains the introduction to limits. Good job.